Okay, we'll get started really soon, another minute or two. Today we're going over practice test 1, and then we can end with any questions you guys might have. I have class at 7, and I need to do some last minute homework for that, so we'll probably end around 6:30, if that sounds okay, which works out nicely because there is like a more official review for the test starting at 6:30, and I know the details for that are in D2L. I don't know what he's going over, but I'm assuming it's also helpful. Just FYI, if you guys want to do like a back-to-back review, if you hate yourself enough to do that. So yeah, I recommend that. But yeah, before we get started, do you guys have any questions at all? I will be posting a recording of this on the Google Classroom. So FYI, this is being recorded, and I'll post it there. Yep, and I will probably also post my version of the test in case you guys want to see my notes. So yeah, I'll get that up as soon as I can afterwards. Usually takes max 1 hour. All right, any other questions? Okay, just feel free to type them in the chat if you need to. Okay, so let's just go through this really slowly, and if you guys have any questions, let me know. Yeah, I'll try to like touch on some big concepts too, which I've written in green. So first one, if d of t represents the distance a car has traveled in miles after t hours, then the derivative of d of t represents the instantaneous rate of change at time t. Okay, so here we just want to remember the difference between average rate of change and instantaneous rate of change, AROC versus IROC. So IROC is a derivative, right? That will be our d prime t. Instantaneous rate of change gives us the slope at a specific point, which is our derivative. An average rate of change will give us the slope between like 2 points. So those 2 points can be really close together, which would give us an estimation of the instantaneous rate of change. Or those 2 points might be far away, which would give us like a secant line. So average rate of change is different from instantaneous rate of change. I'm pretty sure that concept will come up again and again, so just make sure you know that one. So number 1 is true. The instantaneous rate of change is the derivative. All right, revenue function is given by the product of an item's price, P, and the quantity sold, Q. So this one you should just know, revenue function is R equals P times Q. This one is true. Okay, and so whenever we have like the revenue function, cost function, price function, whatever, those all, when you take the derivative of those, you get the marginal function. So if we took the derivative of R, we would get marginal revenue. So marginal revenue equals R prime. Same for price, cost, whatever else we learned during focus sessions. All right, number 3, given the data in table 1, the average rate of change of f of x over the interval from x equals 2 to x equals 4 is 1. Okay, so we want to calculate the average rate of change. When you calculate the average rate of change, you're just finding the slope between 2 points. They gave us an interval here, they're giving us 2 points. We want to find the slope between the two, which will give us our average rate of change. So when we find a slope, we know that slope equals rise over run. Otherwise known as the change in y over the change in x. So you can use either of these two formulas right here. They will both give you the exact same thing. I feel like not everyone is super clear on that, what I've noticed over the past few weeks. If you do y1 minus y2 over x1 minus x2, that will give you the exact same result as y2 minus y1 over x2 minus x1, also known as slope or rise over run, change in y over change in x. Those are all the same thing. So if we plug into one of those, we have 2 points, right? We have 225 and 450. So we can do 50 minus 25 over 4 minus 2. And then we will get 25 over 2. 25 over 2 is not equal to 1, right? So this should be false. Right, so there we found the average rate of change from an interval. Suppose f of x and g of x are differentiable functions, and the derivative of f at 2 is greater than the derivative of g at 2, which is greater than 0. Okay, so the derivative of f at 2 and the derivative of g at 2 are both positive numbers. Derivative of f at 2 is greater than the derivative of g at 2. And this means that f of x is increasing more than g of x at x equals 2. Okay, so we just want to know, what is the derivative here? Derivative is the instantaneous rate of change, right? Tells us, is the function increasing or is it decreasing? So is it positive or is it negative? It also asks us, is it increasing like quickly, as in it has a very steep slope, or is it just like increasing a little bit, it's more shallow? Or if it's decreasing quickly, it's like very steep this way. If it's decreasing at like a very slow rate, it'll be more shallow. It's neither increasing nor decreasing. It will be perfectly flat, right? Slope is 0. So here we know that the derivative of f at 2, at x equals 2, is greater than the derivative of g at 2, which means that our slope here is going to be greater, right? And so we know that it's increasing more quickly. So we know that, yes, that is true. All right, any questions on anything we've done so far? Okay, cool. Number 5, the derivative of f at t equals blah, blah, is given by which of the following? Okay, so you guys need to know some basic derivative rules for this exam. Power rule, sum rule, difference rule, the quotient rule, and the product rule. I think that's it. I just look up like derivative rules whenever I need to remember them, but you guys should have those memorized. Yeah, I don't think you're allowed to use notes. Yeah. Memorize those. And in this case, we're going to use the quotient rule. How do we know to use the quotient rule? Well, we have something on the top, all right, and we have something on the bottom, and they're being divided. When you have something that you're going to take the derivative of on the top, and something you're going to take the derivative of on the bottom, you're dividing them, use the quotient rule, f over g. So in this case, we know that f is going to be 2t to the power of 5 minus 4t, and g is going to be 2 t to the power of 2.4. There we go. Plus 1. Okay. So we know f, we know g, and then right over here I wrote the quotient rule, so it'll be the derivative of f times g minus the derivative of g times f over g squared. Okay, so we have f, we have g. Let's find the derivative of f and the derivative of g, so f prime, g prime. And then we'll just plug that all into that quotient rule and we should get our answer. So derivative of f will be the derivative of 2t to the 5th power. So you should know by the power rule, that would be 10 times t to the power of 4. We can go over that more later if you guys want. But, power rule should just be like, you should just like know it, you know. And then g prime will be 2.4. Oops, I didn't finish f prime. Hold on. Minus 4, right? So derivative of negative 4t is minus 4. Get back to g prime. Derivative of that will be 2.4 times t to the power of 1.4. And the derivative of 1 is just 0 because the derivative of any constant is always 0. So, you know, that's just going to be like a flat line. So no derivative there. Okay, so we have f, g, f prime, g prime. Let's plug it into the quotient rule and get our answer. All right, so we will have, I might have to move these or something. Okay. We'll have f prime, so that's 10 t to the power of 4 minus 4 times g, so that's t to the power of 2.4 plus 1 minus g prime, so it's 2.4 t to the power of 1.4 times f, so 2t to the power of 5 minus 4t. Sorry, we're getting kind of squished. Okay, all over g squared, so that is t 2.4 plus 1 squared. Okay, and then we don't have to simplify this because Our answers are unsimplified, so we just find the one that matches, and that would be the fourth one. All right, any questions on the power rule or the quotient rule? And I'm almost certain that they will either give you the product rule or the quotient rule to do on the exam. So make sure you know those, or they might give you both, but definitely they will test you on that. All right, the derivative of n of t is given by which of the following? Okay, so we're taking another derivative. Don't feel like scared by this. Best thing to do here is try to simplify the equation a little more before you try to approach it. Because we see that we have a variable in the denominator, and you're like, oh no, what do I do with that? Simplify it and it'll become really easy, right? So if we just simplify n of t, we can leave the square root of 5. That doesn't have any variables associated with it, right? So that's just a constant. Don't get freaked out by the square root. It's just another number. It's just like a fraction of a number. And we know that whenever we take the derivative of a constant, we have 0, right? So don't worry about the square root of 5. You're going to end up with 0. Right, then we have 3 over x to the power of 3.2. Remember our exponent rules from last semester or from algebra. We know that when we have a variable in the denominator, if we switch the sign of the exponent, we can bring it to the numerator. If we wanted to bring it to the denominator, we can do the same, just switch the sign. So in this case, we can have 3 times x to the power of negative 3.2. And that is the same thing as this right here. All we did was switch the sign of the exponent on the variable, and we could bring it back up to the numerator. And then we have plus x. All right, so when we take the derivative of n of t, like I said before, derivative of any constant is 0. The derivative of 3x to the power of negative 3.2. Okay, so power rule like usual, we're going to have 3 times negative 3.2 times x, and then negative 3.2 minus 1 is negative 4.2. And the derivative of x is just 1. All right, and that one is, that one is the third one. I think. Yes, that is the third one. Okay, any questions on that one?
I have a question. So, I guess my question is why wouldn't we multiply the 3 times the 3.2?
Yeah, so you definitely would. But in this case, they're just giving it to you like that. So you just leave it like that. It's unsimplified. But yeah, if I were to do this, if it wasn't multiple choice, if it was like a free response, my next step would be to multiply 3 times 3.2. So we would have negative 9.6 x to the power of negative 4.2 plus 1. That would probably be your final answer. But in this case, it's multiple choice. They left it unsimplified, so I just didn't take it that extra step. But yeah, great question.
Thank you.
Where did the 0 come from? Okay, so the 0 came from, yes, perfect. Thank you, Tyler. That is exactly right. Square root of 5 is just another number, right? It's just a constant. Whenever we take the derivative of a constant, just a plain old number, no variables attached, derivative is always 0. Because if you were to graph just like a plain number like x equals 2, or sorry, no, y equals 2, we would just have a line at y equals 2. And that line is just, it's flat, right? The slope is 0. It's neither increasing nor decreasing. That's why the derivative of any plain old number is always going to be 0. The exam, okay, so not really sure about the actual exam. I didn't bother to check, honestly, but I'm sure it's on the course website somewhere. If anyone wants to chime in, it's definitely somewhere or maybe not. Maybe you guys just have to guess. I don't know. But yeah, I'm not sure. I'm sorry. I just know the content. Okay, so given that the derivative of f at 4 equals 12 and f of x intersects the point 4, 3, which of the following provides the correct equation for the tangent line of f of x at x equals 4? Okay, so a lot to dissect here. I wouldn't do this on the exam, but just for like learning's sake, I'm gonna draw a quick graph. It's not going to be very pretty, but just bear with me. Okay, so right here, we know that the derivative of f of x at x equals 4 is 12. So that means the slope at x equals 4 will be 12. Right, so if we're going to find a tangent line equation for x equals 4, our m, or like our slope value, will be 12. All right, and then we also have a point that it intersects, 4, 3, right? And so in that case, I know that when I figure out my equation for that line, I can use those points, y equals 3 and x equals 4. So I said I was going to graph it. Yeah, I should go do that. Okay, so we have 4, 1, 2, 3, 4, and 3, 1, 2, 3. So we know that it intersects this point right here. We also know that the slope of this line will be 12. And so if I like extrapolate, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 1. It's like a very steep slope. Should look something like that. So that is our tangent line. Okay, so remember, this is not the equation of the original function. We don't know f of x. This is not f of x. This is just a tangent line. And remember, like tangent line is just the line through a point that matches the derivative at that point. So our original function could be like we don't know. We don't know f of x. We don't need to know f of x. Just don't get the tangent line and f of x confused. All right, so yeah, let's find the equation of the tangent line. So here they want you to use point slope form. Just an FYI, you can also use slope intercept form. You'll get the same exact answer, but since it's multiple choice, they've already put it in like point slope form in the answers. So to make it quicker on you, way easier on you, just use point slope form for this one. But you know, I personally don't bother memorizing point slope form. Just it's pointless. Yeah. So anyways, point slope form, let's use it. So we'll have y minus y1. So in this case, y1 is 3. Yes, the practice test is on the course website. Sorry, I should have gone over that. If you go to test information, click on test 1 and then scroll down, you have practice test 1 and you have the solutions as well. So we'll have y minus 3 equals m, which is 12. That is our slope. And then we have x minus x1, which is 4. All right, and then we don't have to simplify because it's multiple choice. They've left it unsimplified, so we'll do the same. And that ends up being the fourth one. 1, 2, 3, 4. Yeah, the fourth one. Yeah, so we only use that point 4, 3. I have to clarify on your question, Laura, but yeah, we only need to find the equation of a line. We only need the slope and a point, or we can use 2 points. But they gave us all the information we needed. They gave us m, and they gave us like an example point, which was 4, 3. So we just need a point that line goes through, and we need the slope of the line, or we can use 2 points and find the slope from those 2 points. But yeah, that's all the information we need. We do not need anything else. So the big concept here is recognizing that the derivative at a point is the slope. Because you guys already know how to find y equals mx plus b. It's just like connecting that slope is derivative. Derivative is slope. Hopefully that answered the question. Okay, let's move on. Okay, perfect. All right, a marketing company determines the model for the projected profit, P of T, of a small business in thousands of dollars 2 years after 2015. Research predicts that P of 10 equals 400 and the derivative of P at 10 equals negative 100. All right, and then we need to interpret this in a word problem. So, okay, let's get into it. So we know that P of T is profit, right? Derivative of P of T is marginal profit. Like I said before, like with the revenue function, R of T is revenue, R prime T is marginal revenue. Just remember that like derivative of those businessy terms is going to be the marginal, whatever the term was. Okay, so P of T will give us profit. So we know that when we just have P of 10, and 10 years after 2015 is 2025, not so important here, but P of 10 will be 400. That means that in 2025, our profit will be 400 thousands of dollars. All right, so that eliminates 3 of them. Okay, and so the other thing is that is it increasing or is it decreasing? Okay, so we know marginal profit tells us that if we make one more item, whatever we're making, it doesn't tell us, but yeah, if we make one more item, that's how much it's going to cost to make that additional item. And so marginal, or I guess in this case, that's how much we'll make off that additional item. If it was cost function, that's how much it would cost for every additional item. But yeah, marginal profit, derivative of profit, just tells us that for an additional item, that is how much we will make off that item, or how much we'll lose off that item. So in this case, our marginal profit is negative, right? And so we know that with every additional item we make, or in this case, every additional year after 2025, at that point, we're going to lose $100,000. So marginal profit at 2025 is negative 100, and that means that we are decreasing by $100,000 with an additional year. So that is the fourth one. All right, I kind of explained that weird, but do you guys have any questions about that? Okay. And definitely, I've never taught this class before, but I think they'll pull a couple of things off of the focus sessions. So just make sure you are pretty solid on that content. Maybe review those before tomorrow. All right, determine each of the following limits if they exist. All right, I actually really like these ones. I think they're super easy. They're hard at first, but after you get into it, it's like really quick. Okay, so we're finding the limit as t approaches -2 of q of t, and we know that the graph is q of t. Okay, so as we approach -2, that means we're approaching t equals -2, or like the x. And so in this case, that is right here. So when I find a limit off a graph, I want to look at the limit approaching it from the negative side and the positive side, or from the left and the right. And we will draw an arrow. So as we go to the left, we're approaching y equals 1. And as we come in from the right, we're approaching y equals 0. All right, so regardless of the open circles, the closed circles, we know that if we're coming in from one side and the other side, and we're getting 2 different answers, limit does not exist. We drew 2 arrows, they're not meeting, they're giving us different answers, limit does not exist. For the other one, at t equals 2, we come in from the left side, we get y equals 0. We come in from the right side, we get y equals 0. The limit does exist. What is that limit? That limit is 0. Okay, so if your errors are meeting, you're all good to go. Whatever they're meeting at will be your limit. If they are not meeting, something is wrong. The limit does not exist. If you have I forgot what it's called. It's like a sharp edge. It looks like that, and you're trying to find the limit right here. You will have a limit because your arrows will meet. But you will not have a slope.
I have a question.
Oh, go ahead.
So for the up one, for the one, like the one right there, for the top one, the one that you didn't just draw, if you just had like a dot, like a point that's like, say it's -2, 2, would that have been the answer? Would that have been 2 instead of does not exist?
Not
Does that make sense?
following what you're saying. So
Okay, so at -2, there's like the closed circle and that open circle.
mhm.
What if there was a point, like say at -2, 2, would that have been the answer to the limit? Yeah, like right there.
If there was a point there. So oh, so like if we didn't have this at all, or
Yeah.
okay, so yeah, so our arrows still, if we drew the arrow coming in from either way, we still would not have, oh, if they were like both empty circles. Yeah, so you would not have the limit. Like the limit would still not exist. If you're coming in from both
So that
and they're not meeting, like your arrows are not meeting, your limit does not exist.
so when both arrows are coming in at the same spot and they like hit at the same spot, that would be the answer.
Yes, yeah. Because if you're
Okay.
coming in one way and you're getting y = 2 and the other way is y = 0, no matter if your circles are open or closed or no circles at all, your limit cannot exist because you'll have like two different answers and can't write two answers, right? So when you have like a true limit, either way you come at it, you'll get the same answer. If you don't get the same answer, your limit cannot exist. It's no longer a limit.
I have a question.
Yeah.
Okay, so kind of just following off of that. So say like there was no other points at -2 and it was just 1, then the limit would be 1. Like the only point we had was the dot that's at 1 instead of like the open circle or the one you drew. Would that be the limit, just 1?
Ooh, that is a good question, actually. I don't think they would ask you that. They might ask you like as the limit approaches -2 from like the negative side or however they connotate that. But yeah, I think it would not exist. I don't think they would ask you to find the limit as it approaches that because you don't really have a limit. Like I guess if you had to choose, I would say yeah, it's 1. But that is a good question. I'm not completely sure. I don't think I've ever done one like that before. But yeah, I don't think they would ask you that. Yeah, hopefully not. I will take the fall for you guys if they do. I'll fight for you. But yeah. Yeah, just as a general rule of thumb, I will draw arrows and see if they meet. And if they meet, we're all happy. If they don't meet, limit does not exist. Any other questions about that one? Okay, and then for this one I just drew, you guys should definitely be aware that if we were trying to find the slope at that point or the derivative of that corner point, that is always going to be does not exist. Okay, so our limit does exist. Limit exists, but the slope or the derivative does not exist. And why is this? Well, when you have that corner point, you don't know, like, is it increasing, decreasing? Technically, it's neither, but like, if you approach the limit from either side, your derivative will either be positive or negative. And so you can't find like a good slope for that. So it's not 0. It will be undefined or like does not exist. Yeah, I think undefined is a better term for that. So your limit exists, your slope does not. But yeah, just so you know, if you have like a function that is a straight horizontal line, then your slope is 0. If you have a function that is a vertical line, slope is undefined. All right, so then next up we have to do part C. Okay, whatever, it's fine. We'll work around it. Okay, so this is the limit of the difference quotient. So this is like what we're doing, I don't know, like a week or two ago. It's still taking the derivative, but it's just like a really long way to do it. So this is what we were doing before we knew the shortcuts. This like works for anything, but like takes forever. It's like how we learn to do a derivative. Okay, so yeah, hopefully you guys shouldn't have to do this sort of thing like when you get into higher calculus, if you get there. But yeah, this is just like grunt work everyone has to do. Okay, so limit of the difference quotient. So right here, this is the difference quotient, and we're gonna plug in b of x to find the limit as h approaches 0. And so here we want to plug in 4 plus h into x and put that down, and then 4 also into x. So we're gonna plug in 4 plus h in for this x, which is right there, and then we're gonna do the same thing for 4. So we'll have 2 times 4 plus h. So in that case, we're just replacing that into that x right there, and then minus 4. So that will give us b of 4 plus h. And then we're going to do minus b of 4. So remember to use your parentheses here. Parentheses. B of 4 will be 2 times 4. So we're just plugging in that 4 for that x. And then plus 4. All right, and then that is all over h. All right, so now I'm gonna like distribute, simplify, get it all nice and pretty. So we will do 8 plus 2h, and then minus 4. Then we distribute this negative as well. So we have minus 8, minus 4, all over h. So the negative 4 came from, oh, my bad. I think that should be positive 4. Yeah, good catch. This should be positive 4. Yeah, hopefully that clears it up. So then that positive 4 came from right here. Yeah, my mistake. That is positive 4. Okay, so yeah, that should be right now. Simplify further. So we will cancel out the 8s and the 4s because those both will equal 0. So we'll have 2h over h. And then h divided by h both cancel out, and we get 2. So our final answer here is as the limit approaches 0, our limit of the difference quotient is 2, or our derivative is 2. All right, any questions on that? Make sure you're good with that one. It's like a very basic calculus thing that everybody hates, but we all have to do.
I have a small question on that actually. In some other problems like this one, I've seen where there's still an h in the final product, and then would you have to plug in 0 for h in that aspect?
Yes, great question. You do plug in 0 for h. And
Okay, but
you're like going through and simplifying it is because if you right away plug in a 0 for h, your equation will not give you the right answer. So you simplify it as much as possible, and then like you are certain you did it correctly, you still have h's, you'll plug in 0 for h, and then your final resulting product is your answer. Yeah, great point. You definitely see that pretty often.
This
okay,
is
thank
a
you.
hypothetical question.
Yeah.
If we were to do this like the same exact thing, I don't even know if this will ever happen ever, but if we were to do like the same exact thing, we had an h left over, and there was it said h approaching any number besides 0. If we had an h still left in that situation, would we take whatever the limit of h approaching? So say if it was approaching like 3 instead of 0, would we plug 3 into that h instead of 0?
Yes, well, I don't know actually. I don't want to say yes with like 100% certainty. I think yes, but with the limit of the difference quotient, h is always approaching 0, which is why I'm not sure because I don't think I've done it myself.
Yeah, that's what I thought. It was like a hypothetical. I would have no idea, but
Yeah, you guys are like asking me tough questions today. You guys should definitely ask Dr. Huang like later at 6:30. They're like really good questions about the limit one and then the like h approaching some other number. Those are really, really good questions. Like you guys are thinking. So I don't think that hard, so I don't know. But yeah, great questions. I'm sorry. Not quite sure. Ask him about those. Really hurt his brain. Okay, so two more pages. We can do this. All right. Oh, did you guys have any other questions? Sorry, I like moved on.
I just have a question about the other practice session at 6:30. You said the information for that is on D2L, correct?
Yes, if you go to D2L, I believe that he posted an announcement about it, and then it's also on Piazza as well. But again, I will tell you guys exactly where it is.
It's on the front page of when you log into D2L and then click on Math 124, the comments or the announcements, it's literally there. Just scroll down a bit and it's the code and everything is there.
Perfect. Thank you. Exactly. It is right on D12. So yeah, if you just open that up, you should come across it under announcements. Yeah. Okay, and then he also posted some notes on Piazza and in today's announcement as well. It says review day notes. So take a look at those if you didn't go to lecture today. All right, number 10. Sales of digital books increased rapidly in the last 10 years. Figure 2 provides the plot of the sales of books, S of t, in millions t years after 2005. Estimate the derivative of S at 6. Clearly show your work. Okay, so when we're estimating from a graph, it's really hard to get super accurate, but in this case, the best thing to do is draw a tangent line and then find the slope of that tangent line. So our tangent line is using the derivative at 6 to draw that line. So we find the slope of that line, and that will give us the derivative. And this is only an estimation because we're working off like paper pencil. But if we were to have like a digital graph where we can draw the perfect line, find the perfect slope, it is exactly accurate. In this case, it's going to be like not that accurate, but I will try my best. Okay, so drawing a tangent line, we're going to do this at the point x equals 6. And when we draw the line, we just want to try to follow the graph as best as we can at the point x equals 6. So I'll start by like drawing a really small line. And then I'll try to lengthen it. I kind of like pre-marked where I wanted it to go, so I didn't look too dumb here, but yeah, that's like a pretty good tangent line based off x equals 6. So if you see, I like got really close into x equals 6, drew a really small line, and then made it longer. All right, and then when I want to find the slope of a line, I will use 2 points, do the rise over the run, or y1 minus y2 over x1 minus x2, and that will give me my slope, which is also the derivative at x equals 6. So let me just choose 2 points off this. I'm going to choose 2 easy points. So right here, I have 9, 200. And down here, I have 4.5 and 0. You can use any 2 points you want. Another good one might be like 7 and 100, although that's like a little off. But yeah, I try to look for like the intersecting points or just ones that look easy to estimate. All right, so now we do y1 minus y2 over x1 minus x2. So we'll do 200 minus 0 over 9 minus 4.5. Okay, so you don't want to use 2 points from the s of t line. And that is because s of t is our original function, right? And like if we choose 2 points from there, we're going to create random secant lines that are like not reflective of the tangent line at x equals 6. Right, so if we like chose 2 points, like literally choosing random points, we would find the slope of that line. That line is definitely not the same as this line, right? Or if we chose like this point and this point, we create a line like that. That's not what we want, right? So we definitely don't want to choose anything off S of t. Yeah. Oh, I feel like I'm being kind of mean. No. Like that's a good question. But we don't want to do that because that will give us like the totally wrong line. We're creating a tangent line, and the only reason we're choosing points off that tangent line is to try to find the slope of that. Yeah, be like super careful about that. Don't use S of t. Draw a tangent line and then use that tangent line. Okay, so we get 200 over 4.5, and then use your calculator, and we get about 44. All right, so yeah, we were estimating the derivative at a single point off a graph. To do that, we drew a tangent line and then found the slope of the tangent line. Okay, so it's like, any questions about how we got the derivative of x equals 6?
Oh, I have a question.
Yeah.
So clearly this is just like a not a hypothetical, but just like a just in case type situation. In case we like are not good at drawing tangent lines because we have to like sketch it with our own hands. I didn't get the same like slope as you did because I clearly just used different points that my tangent line happened to nicely intersect. Is that like fine? Like is that
What'd you get is the question.
Well, because my tangent line just like I tried to make it kind of look like yours, like to where your points intersected, but clearly that didn't work because I'm using my hand. So when I did it, I just chose like nice points. My line intersected like 5 and 0, and then like 8 and 200. So I just used those points, and I got like roughly 67. But clearly, it's gonna be different because mine is not. It's like an estimation of a tangent line, and yours is more like nice and solid. So I just wanted to know if that was like fine to get a different answer.
I would say your answer is probably like a touch off. Sounds like your line is kind of like that.
Mine more looks like.
Yeah. So you're like kind of close. The first time I did it last night, I got 50, and then I checked what they did so I could give you guys the same answer as the solution. But yeah, I like there's like a certain point where they're probably like, oh, that's too far off, and then in other cases it's like, oh, it's fine. So yeah, just try to get a really good approximation of what the graph is doing at that exact point. So like I will zoom all the way in, and then of course I have like the nice Apple Pencil, and like it gets a straight line or whatever. But yeah, as long as you're like in the ballpark, I would say between like 40 to 55, that's like pretty decent. But yeah, like it's probably going to be multiple choice, hopefully, for this type of question. So you should be okay.
Okay, I just wanted to make sure because I was like, oh my God, that is nowhere close to 44.
Yeah, it totally depends on the points you used. I think I used, when I did it, I used this point. Oops, I don't know why it does that. Okay, I used this point, and I think I used this point, and I got 50 or something like that. Yeah. So
okay, there is like a grace of like answers that you can get.
For sure. Yeah,
okay.
For sure. Okay, so any other questions on this one? All right. Okay, so we'll go on to B. We'll have to use our answer from A. Explain what our answer from part A means in terms of sales and books and time. Okay, so let's go back and read the question better. So S of T gives us the sales of books. So how many books did we sell? In millions, how many millions of books did we sell T years after 2005? So when we have T equals 6, we know that's 6 years after 2005, so that means in 2011. And then we have the derivative of 6, or the derivative of S of T at 6 was 44. million books. Since it's a derivative, we're going to have books in terms of t, which was years, right? So we'll have 44 million books per year. All right, so when we put it in a sentence, let me make sure I give it to you guys like perfect. Okay, in the year 2011, which was 6 years after 2005, book sales are increasing by about 44 million books per year. Okay, so in 2011, sales increasing by 44 million books per year. All right, so you want to identify your T. So we found out that T was 2011, and then you want to make sure you include those units for your derivative. Whenever you have units on a derivative, it's always going to be something per something. It's never going to be just books or just years, because just books and just years are your X and Y units. So when you have a derivative unit, it's going to be like, I think Y over X. Right? So rise over run, slope, y1 minus y2 over x1 minus x2. These are like all connected. So derivative units will always be something per something. Remember that. Keep that in the head. All right, so determine the equation for the line tangent to s of t at t equals 6. All right, so we already did most of this actually for part C. We drew our tangent line, and now we just want to find the slope, or we found the slope. We want to find the equation of that line, and we can use that slope that we calculated here. Right, so we found that m equals 44, right? We need one other thing to form our equation, and so in that case, I will just choose a random point off that red line, off that tangent line. So 4.50 looks easy. You could also use 9 to 100. You can use 6, maybe like 50 or like 60. But yeah, I just chose an easy one. So we have our slope and we have a line. We're going to plug it into either of these equations. We'll get the exact same thing. In this case, I will do y equals mx plus b, so we can switch it up a little. So I'll plug in the y as 0 and the x as 4.5. All right, so 0 equals 44, 4.5 plus b. And so 44 times 4.5 is 198. So we'll have negative 198 equals b. And so our official equation will be y equals 44, which is our slope, times x minus 198, which is our y-intercept. Oh, 190. Okay. It's a little different from the yeah, it's a little different from the answer key, but it's like pretty close. In that case, they used the point 675. So when they use 675, they got y equals 44t minus 189. So like we were talking about earlier, there's a lot of like wiggle room here, depending on the point you use, depending on the slope you get, blah, blah, blah. So yeah, just do your best, should be okay. All right, any questions about this page? Alrighty, last page, I think, yeah, last page. All right, so when I was doing this last night, I definitely messed it up and I was going off this being like the original graph. So whenever you are doing a test or like any sort of assessment, double check everything, right? And just make sure you check for that prime symbol to see if this is a derivative graph or an original graph, because that will change your answers for this type of question. All right, so here we have 5 points that we need to look at. And we want to see if g of x is increasing, decreasing, or neither increasing nor decreasing. So we're trying to find the actions of g of x based off of g prime, right? So we have the graph of the derivative. This is the derivative graph. And this is the original. All right, so just make sure you keep those like separate. So when g of x is increasing, the derivative will be positive. Okay, g of x increasing, derivative positive. When g of x is decreasing, derivative is negative, right? Because derivative is slope. So when slope is positive, the graph is increasing. When slope is negative, graph is decreasing. When it's neither, the slope or the derivative is 0. Okay, and so in this case, if we were to look at like the units on this graph, we know that the y is slope and the x is just x. Okay, so when we look at x equals 1, we see that we have the point here, y is about -50. So our slope is negative. The slope of g of x is negative, which means that it's decreasing. At x equals 3, again, our slope is negative, so it's also decreasing. At x equals 4, y is 0, right? So that means it's neither increasing, it's not decreasing. Our slope is exactly 0. Neither. At x equals 5, our y is positive, right? Which means that it's increasing. All right, and then lastly, x equals 9. This is also y is positive, so g of x is increasing. Okay, so when derivative is positive, original is increasing. When derivative is negative, original is decreasing. When derivative is 0, original is not increasing, it's not decreasing. It's probably like a flat line at that point. So a good example is if you look at a parabola, at the vertex of that parabola, here or here, slope is 0. So when we have x equals 4, the slope of g of x is probably like at the vertex of a bump. Any questions about 11? Okay, on to 12. Determine the derivative of v of x. You do not need to simplify your derivative. All right, so earlier we used the quotient rule. Now we're going to use the product rule. So quotient was for dividing. Now we're multiplying f and g. So again, I'm just going to identify my f and my g. So purple will be g, blue will be f. All right, so f is x squared plus 4. G is x cubed minus 8x. We find f prime and g prime, so we can plug it into the, how come 3 is decreasing for? Okay, yeah, so we want to make sure that we're looking at the fact that this is a derivative function, right? And not the original function. So we're looking at not what the graph of the derivative function is doing, but is the function negative or is it positive? So at x equals 3, our y is negative, right? And so we know that when our slope is negative, because we recognize that the y of the derivative graph is slope. When the slope is negative, the original function is decreasing, right? When you have a negative slope, it's going down. So we're not looking at what the derivative graph is doing, like in terms of like, is it going up or down? We're looking at, is it negative or positive? So everything above this line is positive, everything below is negative. Would 3 be increasing if we were analyzing g of x? If like the graph of this was g of x and not g prime x, then yes, 3 would be, like at x equals 3, it would be increasing. So if this was g of x, from here to here it would be decreasing. Here it would be 0, or like neither. Here it'd be increasing, 0, decreasing, 0, increasing. So the important distinction to make is that we're looking at the derivative graph. Yeah, perfect. All right, so now we'll find f prime and g prime for number 12. All right, so let's take the derivative of f. We'll get 2x. The derivative of 4 is 0. And then g prime will be 3x squared minus 8. All right, and now we plug it into the product rule. So we'll have f prime, 2x, times, make sure you use your parentheses here. So 2x times g, which is minus 8x, parentheses, and then plus f, which is x squared plus 4, times g prime, 3x squared minus 8. All right, and then we do not have to simplify, thank God, so we'll just leave it like that. So whenever I'm using the quotient rule, the product rule, I find it really helpful to identify my variables. So set one as f, set one as g. Doesn't matter which is which. Well, for the quotient rule, it does. So yeah, just set the first one as f, second one as g. Make it easy on yourself. But yeah, set one as f, set one as g, find f prime, find g prime, and plug it back in. Makes it like super easy. Don't overcomplicate it. Any questions about 12? Okay. All right, a patient ingests 100 milligrams of a drug. The drug metabolizes so that the amount in the bloodstream decreases continuously at a rate of 10%, where T is measured in hours. What is the half-life of this drug? Okay, so we need to use exponential decay. If you guys remember from algebra, so that's like PERT, right? P equals PERT. So P naught is our initial value, P of T is our final value. And so in this case, we know that our initial is going to be 100 milligrams, and then it's going at a rate of 10%. It's decreasing at a rate of 10%, right? So remember you will take note of decreasing versus increasing, because that will affect your rate, whether your rate is positive or negative. And then T is measured in hours. Okay, so half-life, let's make our general equation and then we'll find the half-life. So P of T equals, P naught is the initial value, so 100 times e to the power of r, so r is rate. In this case, our rate is negative 0.1, right? So it's decreasing by 10% every hour. Decreasing means that it's negative, and we want to turn that 10% into a decimal. So we divide by 100 to get 0.1, and that is times t. All right, so when we find half-life, half-life is given to us in like number of hours, right? So we're going to be solving for t. So half-life, we want to find how long it takes to get from 100, which is our initial sample, to 50, which is half of 100. So we'll have 50 equals 100 times e to the power of negative 0.1 times t. And we're just going to solve for t. Right, so I will divide both sides by 100 to get 1/2 equals e to the power of negative 0.1 t. And then I'm going to take the natural log of both sides to get that t out of the exponent. So natural log of 1/2 equals negative 0.1 t. And then I'll divide both sides by 0.1, or negative 0.1. So we'll get rid of that. So we should have t equals natural log of 1/2 over negative 0.1. If I calculate that, I get about 6.93. So if it was increasing by 0.1, or like increasing by 10%, then our rate here would be a positive 0.1. So increasing, positive, decreasing, negative. So I'm just reading the chat. Okay, so kind of depends on the equation you use. Someone is asking about 1 or like, yeah, 1 minus 0.1, so like 90%. Depends on the equation. For this equation, R will be just our like rate. But if you have an equation that has like a 1 minus R in it, then you would end up with 90 or 0.9. But yeah, for this one, it's just R. In this case, R is given to us as the rate. Right? Forgot what the equation is called, but I know what you're talking about. But for this equation, we're just looking for R, so no extra calculation. So half-life is almost 7 hours. Any other questions? Oh, good. Okay, so make sure you know exponential decay. And this is also actually exponential growth. Shoot. When it's decaying, our R is negative. When it's growing, the R is positive. So that equation can go for either decay or growth. In this case, we know it's decay because the drug, the amount of the drug is decreasing because they tell us that. Could you also use that formula? Trying to think. I don't think that would work for this one because they don't give you like, they don't give you a couple different points. So like for that formula in the chat, the time to use that would be if they were like at t equals 0, you have 100 milligrams. And at t equals 7, you have 50 milligrams. Find the formula for that. That would be a good time to use that formula because they give you kind of like 2 different points and you can find that formula using 2 points, just like how you would find like slope intercept. But in this case, I think they really want you to use this exponential decay formula. Compound interest we would use. I'm trying to remember compound interest. At this point in my life, I just Google every formula. So sorry, I don't know these off the top of my head. But yeah, you would use A equals P times 1 plus R over N to the power of NT. In this case, you use M. Yep, that's the one. Okay. Anything else, guys? I know this exam is closed notes, so that kind of sucks. But yeah, try to remember, like try to memorize all of these formulas to some extent. Like exponential decay is much more important than compounding interest, but I do believe you guys might be tested on that. But I don't know if they would give you the equation first. Yeah, not sure about that one. Might be a good question to ask the professor or the TA. All right, the maximum amount of the drug. Oh, last question. Okay, maximum amount of the drug. They probably won't give you the equation. No comment. Hopefully they do, but yeah, I don't know. Maybe ask about that tonight. Yeah, and see. The maximum amount of the drug, which does not cause dangerous side effects in a human, is 150 milligrams. A patient took a 100 milligram dose 4 hours ago. Is it safe for them to take another 100 milligram dose now? All right, so for the pre-health professionals, this one's for you guys. It's definitely when you prescribe medication, you will be doing this kind of math. You will, for sure. Okay, so yeah, we're going to calculate in 4 hours, what will the dosage be in the bloodstream? So we want to find, in 4 hours, how much will we have? And if it's less than 50 grams or 50 milligrams, the person can take another 100 milligram dose and be okay. If it's more than 50 milligrams and they take another 100 milligram dose, they're going to have more than 150 milligrams in their bloodstream. So that would be unsafe. Right, so first we'll just plug in 4 for T and then find out what will the dosage be. I am not sure if he will be reviewing the same practice test. Actually, have no clue. I didn't know he was having a review session until like yesterday. So yeah, not sure. But he might have like a different take on problems. So, you know, if you guys might find it helpful to still go, even if he's reviewing the same thing. Yeah, okay, so plugging in 4 for t. So our equation was P of t equals 100 e to the power of negative 0.1 t. We'll plug in 4 for t, so we'll get P of t. Remember, P of t is our final dosage in the bloodstream, equals 100 times e to the power of negative 0.1 times 4. All right, and then we just put it in the calculator. 100 times e to the power of negative 0.1 times 4. We get P of t, or like P of 4, I should say, equals about 67. All right, so this is more than 50 milligrams, right? This person, after 4 hours, still has 67 milligrams in their bloodstream. So if they take another 100 milligram dose, they'll have 167 milligrams in their bloodstream, which is more than 150, which is more than the safe amount, right? So it is unsafe. They'll have 167 milligrams in bloodstream, which is more than 150. Oh, okay, we made it to the end. Do you guys have any questions on the practice test? And then we also have like 25 minutes if you guys want to talk about any other general concepts. Yeah, let me know.
If it were for something like, if we were doing like doubling instead of like half-life, would it kind of be the same setup, except we would just put like, if it was 100, instead of setting it equal to 50, we would set it equal to 200?
Exactly, yes.
Okay. Sweet.
And you're
Thank
welcome, guys. Yeah.
Thank you very much. This was super, super helpful.
I'm very glad. Yeah.
Yes, thank you very much.
You're welcome, guys. Okay, so piecewise functions and showing work. Okay, so I'll answer the showing work thing. Just show as much work as possible. You're very welcome, guys. Yeah, so like the amount of work I showed is pretty good. I probably showed a little extra work, but just try to show every step. Don't do too much in your head, and then be asking in like terms of like an online. Yeah, I'm not certain with that. I'm not sure if he'll need you to show work. 1 through 5. Okay, so let me go back there. Okay, yeah, how are you gonna record that? So this, I believe, is like on Lockdown browser, right? I'm not wrong. So I don't think he'll ask you to show work. Should be like multiple choice and short answer. Yeah, so yeah, I don't think that will be an issue. I don't think he'll ask you to like type out your work, because I can imagine that would be quite difficult. So yeah, I wouldn't worry too much about showing work. He probably won't ask you to. Oh, okay, I see. Yeah, if he asks you to, just try your best. But yeah. Okay, and then yeah, piecewise functions, right? Okay, so any specific questions about piecewise functions? I can just kind of like talk about them for a while if you want.
Yeah, that'd be fine to just go over like piecewise functions in general.
Okay, yeah, so you guys are very welcome. Good luck to all of you on the, oh yeah, limits, we can do that. Good luck on the exam tomorrow, guys. You will crush it. Just study really hard, okay? And yeah, you guys got it. Just study hard. It'll be okay. It'll get better, guys. So piecewise functions when you find the limit. Yeah, so that's also related to, what was it up here? Number 9, right? So when I'm finding the limit, like I said earlier, go at it from both sides. That's like the universal thing to do. So you go at it from the left, you go at it from the right. Doesn't matter which one's open, which one's closed. Either way you go at it from, if your arrows do not meet in the middle, if they end up in different spots, like this one is going to have a different y value than this one will. Your limit will not exist. At any other point on this piecewise function, assuming there are no other like weird like arrow, like open holes or whatever, the limit does not exist only at this point. At any other point, your arrows will always meet, right? At this point, you have a limit that exists. So with piecewise functions, it's only that one little weird part that your limit does not exist. Otherwise, it's there, right?
I have a question about that.
Mm-hmm.
I have a question about that.
Yeah.
Okay, so sometimes, okay, so say on the x-axis that's like 3, okay? So that's like 3. When it goes like limit like x to, no, like, I don't know. Like underneath limit, how it has that like arrow sign to 3 or whatever, or to 0, you know? I'm not making any sense.
Oh,
right
like limit as x approaches. Right?
Yes, that. Yeah. So sometimes it has that like negative or plus on the top right corner.
Yes.
Would that still be D and E? Like does not exist, or what would it be?
Okay, great. Thank you. You like gave me some material to cover. Yes, great question. So
Okay.
you kind of have like 3 options here. So we have limit as x approaches 3 from the positive side, right? That's the first one I wrote. Let's use a different color. The other option is limit as x approaches 3 from the negative side. Okay, and then the last one, which is what we did in number 9, we had limit as x approaches 3. All right, not from positive, not from negative. You might say like positive 3, but that'll be on the left side, like it'll be in front of the 3. So shoot, let's move this. Okay, so you want to know the difference between the 3 of these. For the first one, we're approaching 3 from the positive side, which means we're coming in from the right, because the right side is the positive side of the x plane system. So when we're coming in from the right, the positive side, we're going this way. We do not face any interruption here, right? It's like a closed circle. We're all good. It doesn't even matter if it's a closed circle. As we get infinitely close to x equals 3, we're going to have a limit. And that limit will be, let's make up some numbers. Okay, here we go. Okay, that limit will be 3, right? So as we come in from one side, we're not worried about the piecewise function at all. We're just worried about coming in from that one side to that point. We don't even touch that point, FYI. We're getting, as we have like a limit, we're getting infinitely close to that point, but we never touch it. That means we do have a limit, and that limit is 3. For the orange one, we're coming at the limit from the left side, right, from the negative side. So as we're coming in, we have 2, right? Y equals 2. It doesn't matter that it's a closed circle because, like I said before, we're never actually going to touch that point. We're getting infinitely close to it, but we will never actually hit that open circle. The open circle is like infinitely small. It is exactly at x equals 3. And our limit never actually hits exactly x equals 3. Just gets really, really, really close to it. So at that point, our limit is 2. But for the green one, as x just approaches 3 straight on, we have to look at it from both sides. So from both the right side and the left side, our limits don't match, right? We have 3 here and we have 2 here. So just for x, as x approaches 3, just like plain old 3, then the limit does not exist. So that was a great, great question. Does that clear it up?
Yeah, that was really helpful. If I remember, it's also in the quizzes. there were like these functions where like, for example, it's like 2x and it's like x, it has to be like less than 1. It was like a list of functions, and then they had like an x value is greater than 2 but less than 4, for example, something like that.
Yeah, so do you want to know like how to plot a piecewise function? That's, I think,
Yeah.
that's what you're referring to. Okay, perfect. Yeah. Well, it's a lot of pressure. I'll just like make one up. So let's do like a 3 system thing. We can have like 2x as the function when x is less than -3. 4 is the function when x is between -3, 7, and then a 7. No, other way. When x is greater than 7, we'll have x squared. Okay, so yeah, so an important distinction to make. This right here in the blue, those are our functions, okay? Right here in the purple, these are like our boundaries. Separate this a little. Okay, so left side is functions, right side is boundaries. So functions will tell us kind of what our graph will look like. Boundaries will tell us when our graph will look like that. So we have 3 different functions on the left, right? And we kind of have like 3 different boundaries that are associated with those functions. So when we graph, from anything that is less than -3, we're gonna have to go this way. Anything that is x is less than -3, our function will look like 2x. Anything that's between -3 and 7, yeah, I will definitely do some limits with this once I draw it. Good idea, thank you. From -3 to 7, our function will just be y equals 4. Y equals ... and then from 7 onwards onto the right, our function will look like x squared. So I will mark this up. Okay. Yeah, so let's draw. So I'm going to start with the top one. Anything less than -3 is going to look like 2x. Okay, so here you could like make a table of values if you wanted. So I would go like x, y, and x could start from like -4, -3, -2, and we'll add more later. Okay, so if I plug in -4, out of these 3 functions, I'm going to do the first function, right? Because that boundary tells me that when it's -4, it's less than -3, so we're going to use that function 2x. So 2 times -4 will give us -8. And then we plot -4, -8. 1, 2, 3, 4, 5, 6, 7, 8. So like right around here. Okay, so that's one point. -3 is another point. So for -3, what we're going to do is we're actually going to plug it in twice. Okay, one time is like the real deal. The other time is like we need an estimation. So let me just do it and maybe you'll catch on. So -3, if we're going to plug in -3 into these functions, we would not do the first function. We would do the second function because on the alligator of the second function, we have this line down here, right? That tells us that x includes -3. We don't have a line in the first boundary, so that tells us x gets infinitely close to -3, but never actually touches -3. Everyone good with that?
That makes sense.
Okay, perfect. So once you like grasp that concept, it becomes a lot easier. So we know that -3, we're going to plug into the second function. And so there's actually no x to plug into the second function. So at x equals -3, our y is just going to be 4. So -3, 4. Yeah, okay. So that will give us the beginning of our second function. But before we move on to the second function, I want to finish the first one. And so I know that there's probably like a line here, right? But I don't know where it stops. It should stop at -3, x equals -3. So we'll have an open circle at x equals -3, but I have to find the corresponding y value. So to do that, I'll plug in -3 into 2x, but that will be an open circle because there's no like line underneath the alligator. So -3 times 2 will be -6. So -6 is right here. And we leave that open because there's no line underneath the alligator. This is just giving us an idea of where to stop our line. So our first function is, let's like, I don't know, like highlight or something. First function is right there. Okay, and that ends in an open circle because x is less than, but not equal to -3. All right, and so then we're starting at -3, and that is a closed circle because it is x is greater than or equal to -3. So when it's equal to, we have a closed circle. And then that will just be 4 until we hit 7, right? So until all the way at 7, it will just be 4 all the way through. Okay, makes sense with that one. Hopefully. So -2 is going to be 4, -1 is going to be 4, 0 is going to be 4, dot, 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 all the way to 7. Okay, and then you're welcome, Ross. Next one will be 7 again. We're going to do it for x squared, right? So our last function has a different domain. It's when x is greater than 7, not when x is equal to 7. So we know we're going to use an open circle. All right, and so we'll plug in 7 for x squared, and we will get 49. We're not going to write that in our table because it's an open circle. So, oh, I did not think this through, guys. Okay, so it'll be like all the way up here at 49. And then at x equals 8, it will be 64. So yeah, it should kind of look like this. Ooh. That was kind of dumb with me. My B, guys. Okay, so yeah, at 49 and 7, we have an open circle, and that would be x squared. I know it kind of looks like that because x squared is a parabola, right? And so I'm just assuming that we're starting like right here in the parabola and going that way. Yeah, so we have 3 different functions, right? And so it's kind of like we've drawn all 3 functions and then we've erased what we don't apply to our specific graph. So piecewise functions, it's like drawing several functions on the same graph, but limiting them to certain boundaries. That's how I like to think of it. The tricky part is just knowing when to put closed and open circles. So you have to look at, is it greater than and equal to, greater than or equal to, or is it just greater than? So you have to look for that equal to. When it's equal to, or when you have that line, it's a closed circle. When you don't have that line underneath the alligator, it's an open circle. Okay, any questions about that? I think we'll do like the limit of this next.
That makes sense. Thank you.
Okay, perfect. Let me run through the limit real quick. So if we're going to find the limit at x equals -3, just like plain old limit, we'll approach it from both sides, right? This way and this way. And we'll see that our arrows do not meet in the middle, right? And so we will have does not exist. If we were to go at x approaches -3 from the positive side, we would have a limit of 4, right? Here, y equals 4. We're just coming at it from one side. It's real easy. That will be our limit. We go the limit as x approaches -3 from the negative side. That's from the left side. We'll hit, I think it was like -6. So our limit is -6. And so that's how we would do -3. So in this case, when we're finding limits, the open closed circle doesn't really matter. What really matters is, are we coming at it from the left side, the right side, or both sides? If it's both sides and it's at like that piecewise point, our limit cannot exist. If it's just coming from one side, our limit's whatever it was. All right, do you guys feel good about piecewise functions now? Or at least better? Good, thumbs up. Great, great. I feel like I had another question in here. A problem like 9C, or how we substitute everything in here. Okay, so let's go to 9C. Okay, limit of the difference quotient. Yeah, so perfect. Yeah, this one's definitely confusing. Let's just do an example problem of limit of the difference quotient. If you guys have any other questions, we'll probably like wrap it up after this problem. Feel free to email me. I'll get back to you guys fairly quickly. So yeah, email me tonight, possibly tomorrow. If you have any last minute questions, I'm really happy to help. So yeah, my email is on Google Classroom, and I'll also drop it here too. Well, let's finish up with this one, and then I really gotta like last minute do my homework before class. So okay. So limit of the difference quotient. I'm going to find an example problem because they usually don't work out nicely if I just make one up. Unless you guys like have an example. Let's see. Shoot, just gotta find like a random one. Let's see. Okay, so we will do f of x equals 3x squared plus 6x minus 4. Okay, and so actually all they have to do is give us, let me make sure I'm saying this right. All they have to do is give us this original function, and then we should be able to find the limit, right? So limit as h approaches 0 will be, we'll have x plus h minus f of x. So we'll have f x plus h minus f of x all over h, and then they'll give us an x. So in this case, we will have the x. I don't know why this website is set up so poorly, but hold on, I will find it. 1 second. Okay, so in this case, we won't use an x, we'll just plug in x plus h. Yeah, I think that's what they want us to do. This is like a little different, but basically same concept. Okay. They've given us this, we need to solve for the limit of the difference quotient. Remember, the difference quotient is this piece right here, and then we have limit, right? Limit of the difference quotient. And so this is like very general right over here, a very general formula. This part is very specific to the problem. And so in this case, when we have this f of x, we want to plug in f of x right here and f of x plus h for that first part. So we need to calculate f of x plus h. So when we have f of x plus h, we're going to plug in x plus h for x. So if it's not too confusing, we'll have 3 times x plus h squared plus 6 times x plus h minus 4. So all we've done is taken this x plus h and plugged it in for every x. Just like if we were to do f of 4, we would plug in 4 for x. When we're doing f of x plus h, we're plugging in that x plus h for x. All right, so we have f of x and we have f of x plus h. We're going to put them both into the difference quotient. So we'll have 3x plus h squared plus 6x plus h minus 4. All right, and then we'll have minus f of x, so parentheses, minus 3x squared plus 6x minus 4. all over h. I don't know why I chose such a long problem, but I'll just kind of like speed through it a little. So I'm going to expand each of these out so we can simplify this down. So x plus h squared will be x squared plus 2xh plus h squared, and that's times 3, plus 6x plus 6h minus 4. Then we're going to distribute this negative to each of these components. So we'll have negative 3x squared minus 6x plus 4 all over h. And last step is to distribute the 3 out. So I'll just like rewrite it. So we'll have 3x squared plus 6xh plus 3h squared. Right, and you can go through it like slowly too. I like zoom through it, but yeah, that's what we should get.
Yeah, thank you. I know that you had a hard cutoff at 6:30, but yeah, I just needed help with the beginning part. So yeah, I'll go ahead and leave with this. But yeah, this definitely helped too.
Okay, perfect. Yeah. But yeah, you'll just simplify it down, combine like terms, and then
Mhm.
I'll finish this and upload it too. But yeah.
Okay, yeah, perfect. Thank you so much.
Yeah, you're welcome, guys. Thank you for coming. And again, good luck on tomorrow's exam. Go to the other guy's review session too, Dr. Hines. I'm sure it's at least helpful, like get more reviewing. But yeah, I'll see you guys next week at the focus session. So good luck.
Thank you.
Thank you.
Mhm.